Okay, this is Math 200. We're looking at the final review. So this will be the last video that I do for you guys. Hopefully you're all safe and well. And here goes. This is what the last test is going to look like. No extra fluff in this one. There's 20 problems on the review, 20 problems on the test. So pretty straightforward. Put this in scientific notation. 1, 2, 3, 4, 5, 6, 7 places we have to move the decimal to the right. So this is a tiny number. So this is 9.19 times 10 to the negative 7th power. So don't forget the negative on that. That's a real common error. All right, through this point, but parallel to that. So if this is a line that we want it to be parallel to, we look at the slope. The slope of this line is 2. That's always the thing in front of the x, y equals mx plus b. And then parallel slopes, remember, parallel lines never cross. Slopes are the rate of change. So the rate of change has to be identical. Otherwise, they would cross somewhere. So the slope is the same. So now we've got the slope of our line. We've got a point on our line, so we're going to use y minus y1 equals slope times x minus x sub 1. This is x sub 1, this is y sub 1. So y minus 5 equals 2 times x minus 3. Bam, bam, 2x minus 6, y minus 5. And now we want to solve it for y. They want it in slope-intercept form, so solve for y. So all we have to do is add 5 to both sides. That'll isolate our y is equal to 2x minus 1. All right. And then the final, word problems. We love word problems. Or wait, no, the other thing. You hate word problems. Or application problems. That's the only one with words in it. That's the only application problem. It's going to look like this. It's almost a mixture problem. It's very similar to a mixture problem, right? It sets up like a mixture problem. So they sold 356 tickets. So look, x plus y is equal to 356. So adding the total tickets of adults plus the total tickets of senior citizens is 356 tickets. Now we make a money one. This is kind of the framework for our money one. We're going to say, okay, $20. So X are the adult tickets sold plus $12. So Y is the senior citizens tickets sold. And then equals, and this is where it deviates from a true mixture problem. They gave us this amount, the 3,872. In a true mixture problem, we would have a percent and we'd be multiplying it by the 356. But, so it's really close though. So a system of equations. We can solve this any way you want. You could do substitution if you like. I'm going to do elimination or the addition method. So I'm going to multiply everything in this one by negative 20. Because, why am I doing that and not negative 12? I want negative 20 because I want to get rid of the x's. They want senior citizen tickets only. They don't want both. So they want y. So this will get me y pretty quick. All right, so we multiply all that. We get negative 20x minus 20y equals, I need a little calculator help for that one. 356 times negative 20 is negative 7120. And then we got 20x. We leave the second one alone. Don't change a thing. Leave 20x plus 12y equals 5872. And 5872. So this is what we have. The x's cancel away. The y's, negative 20 and positive 12 is negative 8y is equal to, and negative 7120 plus 5,872 is negative 1248. And then we divide by negative 8. And so that divided by negative 8 is 156 senior citizen tickets. So 156. Look and make sure you can see all of the work. You sure can. Excellent. All right. So, yeah, that's a tough one. It might be one of the hardest ones on the test. All right. So there we are, 1, 2, and 3. Let's press on. Okay. So, oh, don't skip number 4. Goodness gracious, I've had students in the past skip that one. They're like, oh no, it's that ordered triple one. I hate those. I'm not going to do it. This one's super easy. We made a super easy version of this, and it'll be super easy on the test. So look. Z equals 4. They already gave you Z. It's 4. So that's the easiest points you're going to get. Now, to find y, we just take that and sub it back in. You don't have to do the elimination method or anything. It's just sub in actual numeric values here. And now look, it's just a single variable, and we're back to week 1. Two-step equation. Isolate the variable. And divide by the number in front to get the coefficient to be 1, right? 1y equals the name of the game. 11. So now 2 down, 1 to go. We're going to take the 4 and the 11 now and sub it into that. So we have x we don't know, but we know y is 11 and z is 4. And now we got x plus 22 minus 8 equals 15. And I don't know if anybody remembers this, but at the very beginning of the year, I said you're going to be solving equations all the way to the end. Here we are at the final review. Here we are solving equations, combine like terms. That's x plus, what is that, 14? Equals 15. And now we want to isolate the variable, get x all by itself. So we will subtract 14 from both sides of the equation. And x is 1. Done. So, I mean, it was tedious, I guess, but don't skip it. It's a pretty easy problem. It isn't that involved. All right, so then factoring. We love factoring. X squared. So you want to find the greatest common factor here. Definitely I can pull out x squared, right? Factor an x squared out of everything. And then between 7 and 21 and 14, that's 7. So the GCF here is 7x squared. So I put a 7x squared down. I do a big old empty set of parentheses. And now to figure out how to populate inside the parentheses, whatever you wrote down out front, you divide that into each term. I was thinking the Darth Vader line. We'll have to destroy them ship to ship. So look, we're destroying them ship to ship here. 14 divided by 7 is 2. There's 6 x's on top. There's 2 on the bottom. And cancel 1 for 1. So there's 4 left. X to the 4th. Plus 7 into there is 3. 4 on top, 2 on bottom. Cancel 1 for 1. So x squared. X squared on top, x squared on bottom, gone. Now, be careful. Lots of people just circle that, and that's it. No. 7 divided by 7 is 1. It's still plus 1. That doesn't zero out, all right? So 7x squared times quantity, 2x to the 4th plus 3x squared plus 1. All right. Let's do the next problems. All right, so number 6 is factor by grouping. Okay, so when you factor by grouping, you should feel like a magician, a magician here. We are going to do the GCF of the first two. So just the first two. What can I factor out of 18 that I can factor out of 2i? The answer is 2. You put that down, you do an empty set of parentheses, you divide that by 2, you divide that by 2, and you end up with inside there y minus 9. Then, there's still a plus there. We factor the GCF out of the second two. Well, xy minus 9x, that would be an x, right? An x. And a big old empty set of parentheses. You divide that by x, you divide that by x. And then look, the x's cancel, we get a y. X's cancel, we get a 9. Now look, we've got, this is the magician-y part. Now look, I've got a binomial times 2. I've got that same binomial times x. So I'm now, for the next trick, going to factor out that binomial. Just like how I factored the 2 out, and just how I factored the x out. I'm going to factor out an entire binomial. And so, minus 9, minus 9, and then look what happens. That cancels. Down comes the 2. That cancels. Down comes the x. And the plus is still intact. And there we are. We factored it. That's factor by grouping. We do that when there are 4 terms where there's a GCF on the first 2 and a GCF on the second 2. And then we ended up with the exact same binomial. All right. Number 7, that's just factoring. Kind of, sometimes we'll refer to that as unfoil factoring. Remember, I said you can look at the suspects, right? Things that multiply to be negative 70. We'll make a list of suspects here. Negative 70 and 1. Negative 2 and 35, negative 35 and 2. But here's the thing. These are a list of suspects, but it has to add up to be 3. 7 times 5, 35. Oh, there we are. Negative 7 and 10, or negative 10 and 7. There it is. We need this one. It's got to be that one. The negative has to be on the 7, and the 10 has to be positive because it has to add up to positive 3. This one adds up to negative 3. Lots of students think, oh, no, it doesn't matter which one I take. In this case, it does matter which one has the negative on it. If they're both positive or both negative, then it doesn't matter. Now, order doesn't matter. It doesn't matter if you write x plus 10 first and x minus 7 second. But the negative has to be on the 7 and the plus has to be on the 10. And there we have it factored. All right. 8 is a lot easier of a factoring problem. It's 81x squared minus 49. So we're going to do... Really, these are conjugates. This is a difference of 2 perfect squares. So that's a perfect square minus another perfect square. So unlike this one where we had a big list of suspects, this one, you just take the square root of the first term, you take the square root of the second term, so 9x and 7. So we get 9x and 9x, and then 7 and 7. And now you just, one gets a plus, one gets a minus. That's why there is no middle term. There's no x term because they canceled each other out. Plus 63x and minus 63x. No x's. All right? Ooh, and I picked 81 on purpose here. Be careful on the test. A lot of times when students take the square root, you're done. You took the square root of it. It's 9x. But people look at it and go, ooh, 3 times 3 is 9. And then they do another square root. Well, now you just did the 4th root. Don't do that. We don't want the 4th root. We want the square root. All right. Okay. Here, let me do 9 and 10, and then we'll stop this video because it's getting long, and then we'll do. I'll do a second video with the other 11 through 20. All right. So let's do 9 is x plus 10. Ooh, this one is a hard problem because we have to solve. Now we're solving second degree equation. Remember, fundamental theorem says you find me 2 solutions if I give you a second degree. So I do the distributive property there, add the 9 to both sides of the equation. So we have essentially gotten all of it, everything over here equal to 0. And now we have to look at our list of suspects. For positive 9, that's 1 and 9, or 3 and 3. Well, it has to be 1 and 9, so x plus 1, x plus 9 equals 0. So now we have it broken down. We took a second degree thing and broke it down into a first degree binomial times a first degree binomial. But now we go way, way back to when you first learned your multiplication tables. 0 times anything is 0. So the only way when I multiply anything by 0, I get 0. That's also if I get 0 through multiplication, one of them has to be a 0. So we set this equal to 0 and that equal to 0. And then we go back to week 1 and solve a one-step equation. -1 and -9. 2 solutions, -1 -1 and -9. I can check them back. -1 times 9 is -9. -9 times 1 is -9. So you can put them back in to check. All right, and now we'll just do 10, and then we'll call it a video, and we'll do the second video. All right. So here we are. They want to know, oh, just the domain. Easy peasy lemon squeezy. So we don't care about the top at all. We don't care about the numerator. It's all about the denominator, and the denominator cannot be 0. That's cannot equal sign right there. And so -7 divided by -1. And now you might not even have to show any of this work. You could have maybe looked at it and said, well, 7, we'll zero it out. So that is all you have to put. You can say all real numbers. If you don't want to write the shorthand like that, you could just say all real numbers except 7. And that's the way to write it out in words. All right. Okay. On the next video, we will do 11 through 20.